Okay, my name is Greg DeBorn, and today we're going to learn how to plot a typical refrigeration cycle on a pressure enthalpy diagram. The cycle we're going to use today is an example of a medium temperature application where we're controlling a box temperature of about 35 degrees, and we're operating with an air-cooled condenser, and the ambient air temperature around the condenser is around 85 degrees Fahrenheit. So to represent what this cycle would typically look at, the first thing we usually do is we have to plot our low side pressure, the low side of the system, and we usually pick what we're going to do is, since we're going to have a box temperature of 35 degrees Fahrenheit, we're going to have to plot an evaporator temperature of around 20 degrees Fahrenheit, and you'll see the lines of constant temperature right here in the saturated zone. We want a saturated evaporator temperature of 20 degrees, so we're going to plot the red line right along the 20 degree line. And then for our high side pressure, what we're going to do is, since we're operating at around an ambient temperature of 85 degrees Fahrenheit, knowing that in that temperature range of ambient, typically our saturated condensing temperature will be about 30 degrees Fahrenheit above the ambient, so 30 plus 85, we're going to be looking at a saturated condensing temperature of around 115 degrees Fahrenheit. So I'm going to go and draw my top line right here at around 115. See, there's 100, there's 120. This looks like about 115 degrees Fahrenheit right here. And there's my top line. So now what I'm going to do is I'm going to have to anticipate what some of the temperatures are going to be in the various points of the system. One of the things I can anticipate is that typically in our condenser we should have around 10 degrees of subcooling. So if I take 10 degrees of subcooling, we're condensing at 115 degrees. My liquid line temperature as the refrigerant leaves the condenser should get down to around 105 degrees. You'll see here's the 100 degree line here and 120. So it looks like 105 degrees is right about here. So I'm going to put that dot right there. I can also anticipate that we should have about 10 degrees of evaporator superheat. So you see here's our 20 degree saturated suction. If we come out along this line, you see here's the 20 degree line and the 40 degree line. If we come in between here, that's about 30 degrees right there on our suction line. Okay, we can also anticipate that we'll probably have another 15 degrees of superheat that we pick up on the suction line, so that the temperature of the suction line as the refrigerant vapor enters the compressors, I'm going to anticipate it's going to be around 45 degrees, so I put that point right there. And the next two things I can do is I can anticipate a typical discharge temperature for this system. The temperature on the discharge line is probably going to run us around, about 150 degrees Fahrenheit. So there's 150 right there. And then the other thing is typically that would represent the temperature on the discharge line 6 inches down the discharge line away from the compressor, knowing that back in the compressor itself, the temperature of the discharge gas is probably about 50 degrees warmer, so that would put us at a temperature of about 200 degrees Fahrenheit right here. After we've determined all of this, then we can simply move this line over here and come down, take this line, start at this point,